All right, so in day 2, we are going to be talking about um, angle measures in degrees and in a new term called a radian. But we're going to focus more on degrees first. So in the previous lesson, we worked with only acute angles. We were doing sine, cosine, tangent, and all of that. Uh, SOHCAHTOA, all those angles that we were looking at were acute or less than 90. Now we're going to talk about angles of any measure, more than 90, more than 360 actually, and even negative angles. So an angle is made up of an initial side and a terminal side. So the initial side is like our starting point, our fixed side. So we fix one side and call that the terminal side, and then we rotate the other ray called the terminal side about the vertex or pointy part of the angle. So if we look at this here, this can kind of give us an idea where this is our initial side where we start, and we're rotating this many degrees, and we end up right here, and this is our terminal side or where we ended. So we rotated counterclockwise. Now, this is also based on a coordinate plane, and you may not have realized that. Like, here's your x-axis and here's your y-axis. So your quadrants 1, 2, 3, and 4, those are some things that we still need to remember when talking about this stuff. So, like I was saying, a positive angle, we're going to go counterclockwise with that. A negative angle would go clockwise. So like I was saying, a positive angle, we're going to rotate counterclockwise, and a negative angle, we rotate clockwise. So here again, we are talking about a positive angle because the arrows are telling us we're rotating this way. If the arrows were going in this direction, this is a negative angle because now we're going in the other direction. Even though we ended up in the same spot, the way you rotate determines if it's a positive or negative angle. Then we have something called standard position. So standard position of an angle is when we have the vertex at the origin, 0, 0, 0, and its initial side lies on the positive x-axis. So this one was standard position because our vertex is at the origin, and our initial side is the positive x-axis. So down here, we're going to draw angles, and until we get good at understanding where these degrees would be in the coordinate plane, I like to label 0 degrees, and then if I go a quarter of a circle, this would be 90 degrees. This would be a half circle rotation, or 180 degrees, 270 degrees, and a full circle is also 360 degrees. So 360 and 0 degrees line up at the same spot here. So that is something important to understand. So 240 degrees, it's bigger than 180, but less than 270, but it's also closer to 270 than it is to 180. So when I draw my initial side, my terminal side will be down here, and since it's a positive angle, I go in this direction. So that would be a positive 240 degree angle. Now I'm not going to get super serious and get a protractor out to make sure it's exactly 240. Just you were estimating based on our knowledge. Now letter B is negative 65 degrees. Okay, so negative 65. We're going to be going clockwise now. This is still 0, but now here, instead of this being 270, it is negative 90 degrees because it's a quarter circle. in the clockwise direction. This is negative 180 degrees, negative 270, and also negative 360 here. So negative 65 is less than, well, it will be less than negative 90 degrees. We're talking about rotations. So it's going to be around here, and we're going to draw it this way. So that is a negative 65-degree angle. Now, with 405 degrees, right, again, 0 degrees is a positive angle, so 90, 180, 270, and 360 is going to be more than one full circle. But how much more than one full circle? Well, if we subtract 360, that gives us 45. So it's 45 degrees more than a full circle. So if we were to draw this, here's my terminal side, or sorry, my initial side. I'm going to draw my terminal side at a 45-degree angle. Now, if I were to just do this, that's not 405 degrees because that's less than a circle. That's only 45. So what I need to do is I start here. That is my full circle rotation, and now I go a little bit more. That would be my 405-degree angle. I went that full 360 degrees in a circle, and then I went 45 degrees more. Right. Then negative 150, so 0, negative 90, negative 180 degrees, negative 270 degrees, and negative 360 degrees. Now it's going to be not as much of a rotation as negative 180, but pretty close. So if here's my initial side, my terminal side could be about there. And that will be my rotation. Okay? So we're going to get good at estimating where these angles are. Which quadrant does this terminal side lie in? The initial side will always be the positive x-axis. We're concerned about where that final side or that terminal side is, what quadrant we are in. All right, the next thing we're going to talk is about something called coterminal angles. Now, coterminal angles are two angles in standard positions where they're terminal sides that coincide or lie on top of each other. So, for example, when we were looking at this angle here, 405 degrees, and we subtracted 360 and said, okay, we're 45 degrees more than a full circle. So we drew 45 degrees, but in our rotation, we went a full circle and then 45 degrees. Now, the initial side and the terminal side would be the exact same if I were just drawing a normal 45-degree angle. So these two angles are coterminal, 405 and 45, because the initial side and terminal side are in the exact same spots. It's just a different amount of rotation. So down here, we're going to draw the angles in standard position, and then we're going to find one positive and one negative coterminal angle. And the way we do that is we're going to add or subtract a circle, which is 360 degrees. So let's draw these first. So 135 degrees. Okay, so it's again 0, 90, 180, 270, 360. So 135 will be between 90 and 180. So let me draw my initial side, and then my terminal side will be in there. And it says a positive angle, it goes this way. So now I'm going to take 135 and add 360. That's going to be my positive coterminal angle. So that will be 495. And then I'm going to do 135 minus 360, and that's going to be negative 225 degrees. So those three angles here, those three angles, 135, positive 495, and negative 225, all those angles have the same terminal side in standard position. They start on the positive x-axis and they end in quadrant number 2. That's where the terminal side is. All right, so negative 75 degrees, again 0, negative 90 degrees because we're going in the clockwise direction now. Now, negative 75, if this is my initial side again, will be close to negative 90, but not quite. So that would be our angle. Now, you might say, well, that is kind of the same thing you drew for negative 65 degrees. Again, we're just getting estimates. I'm more concerned on, about where does that terminal side lie, in what quadrant are you in? Okay, so now I'm going to do negative 75 plus 360. That will give me my positive coterminal angle. So that is going to give us positive 285. And then I'm going to do negative 75 minus 360. Okay, so minus 360 instead, that's going to be negative 435 degrees. So again, these three angles, negative 75, positive 285, and negative 435 degrees, are all going to lie, that terminal side, right here in the fourth quadrant. All right, now positive 220 degrees. Okay, 0. We're going in the positive direction this time. And 220 is, again, between 180 and 270, so my terminal side will be there somewhere. And I'm going in this direction. And then 220 plus 360, that's 580 degrees. And 220 minus 360, that is negative 140 degrees. So again, coterminal angles, we are going to be adding and subtracting a circle from the original angle. All right, so the last thing we're going to talk about is called a radian measure. Now, a radian is another way we can measure angles. We have degrees, but we also have what are called radians. And a radian measure is mostly used like in advanced math classes, pre-calculus, calculus, and so on. And it's the measure of an angle in standard position whose terminal side intersects an arc length r. So what that means, the math definition doesn't sound very appealing. What that is saying is that if we have a circle that has a radius of r, let me use maybe this one. I don't like that one. So if we have a radius r, if we were to take this at this length and translate it right here as an arc length, so if we were to take that radius and translate it here, a radian would be the rotation from here to here, this angle. That angle measure is 1 radian. And we could keep going and add 2 radians, 3 radians, and 4 on, and so on, all the way around the circle. Now, because the formula for circumference is 2 pi r, there are 2 pi radians in a full circle. So 360 degrees is equal to 2 pi radians. And if you take half of that, 1 pi radian is 180 degrees. Now, to convert back and forth between radians and degrees, we use these formulas, and they're reciprocals of each other. So let's, in example 3, we're going to convert degrees to radians, so we're going to be using this formula right here. So 315 times pi over 180. Now, our radians always have to have pi in them. So we're not going to type this all in the calculator and simplify it. We need to leave pi alone. So I'm just going to multiply straight across first, 315 pi over 180. And I'm going to leave pi there, but I'm going to simplify 315 over 180. And that is going to be 7 pi over 4. If we simplify the 315 over 180, that's 7 over 4. Then letter B, convert negative 50 degrees into radians, so negative 50 times pi over 180. That's negative 50 pi over 180. And now we have to simplify negative 50 over 180. That's going to be negative 5 over 18. So the radian measure is negative 5 pi over 18. Now going in the other direction, radians to degrees, I multiply by the reciprocal of that. So 180 over pi instead of pi over 180. So pi over 6, I'm going to multiply by 180 over pi. And the pi's will cancel out, so I'm left with 180 over 6, which is 30 degrees. So the pi's, if you're converting from a pi radian to degree, pi's should cancel out and you're left with just an angle measurement in degrees, a whole number. Right, now negative pi over 12 times 180 over pi. Again, the pi's cancel, so it's going to be negative 180 over 12, which is negative 15 degrees. So that was our introduction to angle measurements, focusing a lot on angles in degrees and introducing the idea of radian. Next time, we're going to spend a lot more of our time talking about radians and how to draw angles in radians as opposed to degrees. So thanks for watching. Make sure to like this video and subscribe.